Hi. In this video, we are going to look at a couple examples of solving algebraically and then transfer that over into our knowledge of trig and see how they compare and then what parts we add on. So just a quick review of kind of solving quadratics in a couple different ways. So in this video, the problems that we're looking at have an x squared term and an x term and also a constant term. So the first thing we're going to try to do is see if it can be factored. Okay, so factored means we would probably want to set up two parentheses. Notice the numbers are really small. So in general, we're probably just going to want to try guessing and checking. So in other words, 2x squared, right, has to be made of 2x times x. So no choice there. And then the 1, or negative 1, has to be 1 times 1. I like to kind of hold off on the signs, SIGNs, and kind of check if I can see what they should be. So, and I do that by looking at the outer term, that's 2x times 1, and the inner term, that's 1 times x, and I want to add those together to make negative x. So I can see I need the 2x term to be negative and the 1x term to be positive. So that's how I decide on those signs, is looking at the outers and the inners. All right, so once I have my factors and I'm happy with them, then I set each factor equal to 0 to solve. So 2x plus 1 is equal to 0. You can subtract 1 and divide by 2. So do that one time maybe. 1 and then divide by 2. So you get x is equal to negative 1/2. And then here, x minus 1 is equal to 0. So you're going to add 1 to both sides. You get x is equal to 1. So we have two solutions to quadratics because of the x squared. All right, the second one, similar problem. I notice I have an x squared term and an x term and also a constant term. That constant is on the other side of the equation. So I will always, for factoring, want to add and make sure everything is on one side of the equation. So x squared minus 3x plus 2 is equal to 0 would be my first step. Make sure it's equal to 0. All right, now I'm going to try to factor. X squared would just have to be x times x. And then 2 needs to be 2 times 1. I need a positive, so I could either have two positives or I could have two negatives. So a negative 2 times a negative 1 would give me that positive 2. And notice I need a negative 3 there, so I'm probably going to need a negative and a negative. Checking that outer and the inner term, I got minus 1x and minus 2x, so that makes negative 3x total. So I'm happy with my factoring. My final step then is to say, well, then x minus 2 is equal to 0. So x equals 2. And x minus 1 is equal to 0. So x is equal to 1. So there's my two solutions. All right, so now let's translate that information into trig, stuff we already know, and then we will tack on trig that we already know as well. All right, so I notice that I have a cosquared term and a cos term and also a term without a cosine. So it really is set up exactly the same as number 1 here. So you do have the choice to say, well, what if I said that I don't like working with cos theta, so I make that into an x. So then I would have 2x squared minus x minus 1 is equal to 0. Notice this is the same factoring we did above, so the answers will still be the same. So we would end up doing the factoring and then getting x is equal to negative 1/2 or x is equal to 1. So once we've done that, that's the end of algebra. Now we need to trig. So we're going to change cosine x back to, x back to cosine theta, which is equal to negative 1/2, and then x back to cos theta, which will be equal to 1. So now I'm going to say, okay, I recognize cosine can be the ratio negative 1/2, definitely a unit circle special value. Cosine is negative in quadrants 2 and quadrants 3. okay? And then if cosine is -1, that's this side is the short side, the adjacent, over 2. So that triangle is a reference 60, or pi over 3, right? That's the reference angle. So theta is going to be equal to 2 pi over 3 in quadrant 2. And then over here, that would be 4 pi over 3 in quadrant 3. I'm kind of leaving a little space because those are my answers for the solutions to 0 to 2 pi, right? Just one time around the unit circle. I just want those two quadrants. But I am also supposed to do the general solution. So the general solution, I'm going to add 2 pi times k to each of those, and then that automatically is the general solution. I would just keep going around the circle to get more solutions. So there's 2 of my solutions. Okay, I don't want to forget I also have cosine theta is equal to 1. Where's cosine theta equal to 1? Ah, right here at 0. Okay, so this one, theta is equal to 0. I don't have to also write 2 pi for this because notice I put a bracket for the 0. 2 pi, I don't need to also include that value. But when I do my general solution, I will add on 2 pi times k. So I have 3 total solutions for the answers in 0 to 2 pi. And then the general solutions, I have 3 little configurations of those as well. All right. So for number 4, you'll notice that this one is set up a lot like number 2 in that I have the squared term minus 3 times the single variable equals -2. Now, if I don't want to translate these into x, I certainly don't have to. I can factor with cosecant theta as my variable. So, the first thing I would do is add 2 to both sides, just like above, and then I would set up my factors. And then the first term would need to be cosecant theta and cosecant theta to make cosecant squared theta. My last term is 2, so that has to be 2 and 1. And then I want it to be negative in the middle, so I make those 2 negative. Okay. So now I would solve for each factor to be 0. So cosecant theta is equal to 2, or 1 equals 0, so cosecant theta is equal to 1. And now I need to trig. So cosecant goes with sine, right? So this is where the sine of theta is a half. Okay, flip over that fraction. All right, I know sine of theta, positive a half. We're in quad 1 and quad 2 for sine being a half. Let's see. Oh, this is where the opposite side is 1. So this triangle, the small side is opposite. So that is a 30-degree reference angle, or pi over 6. Okay, so theta is equal to pi over 6 in quad 1. And then in quad 2, that would be 5 pi over 6. And then, of course, I do want to add on my 2 pi k to each of those for the general. So there's my solutions there. And then I say, well, cosecant would be 1 in the same place where sine would equal 1. And sine equals 1 up here, right? This is the point 0, 1, cosine, sine. So that's pi over 2. So theta is equal to pi over 2. And then I just want to add on 2 pi k to that for the general. So I hope you can see how you are familiar with this algebra. You're going to do it, and then you're going to finish the problem off with some unit circle trig. So now you're going to complete the next 2 problems that are very similar, just with different numbers, on your own, and try to find the solutions there. Good luck.